Greetings everyone. Today we're going to talk about another important topic of compiler design is regular expression to deterministic finite automata, or which is in short known as RE to DFA. Now there are 5 steps of converting a regular expression to DFA. Initially we'll be given a grammar and we'll be asked to convert that grammar to a DFA. So our first step will be augmentation. So what is augmentation? We have to add an hash at the end of the grammar if it is not present. So let's say we have been given a grammar like this, and we'll be checking that is there a hash at the end. We can see there isn't, so we're going to add it at the end of the grammar. So this is our step 1. Our second step is we have to draw a syntax tree. There is a precedence order given, which is we're going to select or choose or give priority to which one in the beginning of our drawing the syntax tree. We can see the brackets at the top, then star or plus, or say then dot, that is multiplication sign, then is an or sign. So let's see for this grammar how we can do it. We can see since the brackets are at the top, so we're going to first start with the brackets. So here are 2 brackets, so we're going to first draw for this one. So here we can see initially what we're going to do is we're going to write all the terms there are, like letters A, then B, then A, B, B, and hash. We're going to write all the terms, all the letters here, and we're going to assign a node number to all of them. Like this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So these are the node numbers here. Now we can see that for A and B there is an OR sign. So what we're going to do, we're going to add an OR sign here, and they're going to connect these two. Thus we have drawn for this part. Now there is a this whole expression has a star sign on it. So what we're going to do, we're going to just simply write another line and draw star. What we actually understand that from this part we have completed A or B, and from this part we have completed A or B star. Now we have to complete the rest of the parts. So we have completed this part. Now this part and this part, it's a multiplication, and the same things for the rest of the terms. So what we're going to do, we're going to add a multiple sign. So I have written here a multiple, and then we're going to just join them. Similarly for the rest of the terms, and for this one also, and for the last one. And thus my syntax tree has been drawn. So what we have done here, for each of the terms we created a relationship. For this part we have created this portion, like when we into these two, then our string is A. This part is completed. When you join this part, this part has completed. For this one, this part has completed, and for this one, this whole part has completed. So for this whole grammar we have created a syntax tree. So here it's a better version. You can see here the labeling is not necessary for this term, like these labelings are not necessary to draw. It's actually for your understanding. So you are going to just draw this part. We have completed our step 2, that is drawing a syntax tree based on the grammar. Now is step 3. What is it? We have to find the nullable, the first pass, and the last pass. What are these things? We're going to see one by one. Let's just see that what does it say. If there is a leaf node, like these are the leaf nodes. If there is an epsilon, then it is by default nullable. We're going to say it won't have a first pass, it won't have a last pass. These are just empty. We're denoting these as empty. Label leaf with position I. That is, initially by default all of the leaf nodes are false. These are not nullable. All of these are by default false. Its first pass will be the same as its node number. That is, here it has 1, so its first pos will also be 1, its last pos will also be 1. For this node, its first pos will be 2, its last pos will also be 2. For this one, its first pos will be 3 and last pos will be 4, and sequentially for the rest. But this is only for these leaf nodes. Now, this is an OR condition that has been told that if C1 or C2, if either any of them is nullable, then this term, this OR part, will also be nullable. And if it is, and its first pos will be the first pos of C1 union first pos of C2, and its last pos will be the last pos of C1 union last pos of C2. Then comes multiplication. If C1 and C2 both are nullable, then this multiplication condition is also nullable. So it's for its first pos, if C1 is nullable, first pos of C1 union first pos of C2, else first pos of C1. For the last pos, if C2 is nullable, last pos of C1 union last pos of C2, else last pos of C1, sorry, C2. And if there is a star condition, that is, then we're going to say it is also by default nullable, and its first pos is first pos of C1 there because there is only one child, and last pos is C1 because as it is, it's the last only one child. So we have in general understand what is how we can figure out the nullables first pos and last pos. Yes, you still have confusion, so let's see the examples and find out. So here is the chart I have given here and also the diagram, and from the diagram for this grammar we're going to now find the first pos, last pos and nullable. So by default we have told that all of this will be false. So let's write here if okay. Now let's see what is the first pos for this. It is first pos is its number only for this case. So let me just write, we're going to write the first pos and last pos in second bracket. For this one, the first pos we write it on the left side and the last pos on the right side. So this is first pos and this is last pos. So I have written all the first pos and the last pos for these leaf nodes. Now here is an OR condition. So for OR condition, what is its nullable condition? Say that if C1 or C2, either one of them is nullable, then it is nullable. Its childs are A and B. We can see that A is not nullable, B is not nullable. That means or this OR condition will be false. That is, it is not unnullable. So I am writing here F. What is this first pos? It says since this is an OR condition, its first pos will be the union of both. Its union of both, I mean the first pos of child 1 and the first pos of child 2. First pos of child 1 is 1, first pos of child 2, that is B, is 2. So let's write 1, 2. And thus the last pos is same, the union of both child's last pos, that is 1, 2. Now what we're going to do, there is a star condition. So in star it is a that by default it will be true. So let's just write here T. What is the first pos? First pos will be the same as its child 1. So 1, 2. And for the last pos, same. As the child has C1 of the last pos is this one, so it will be the same as this one. Now comes the AND condition, this multiply. For multiply we can see here C1 and C2. If C1 and C2 both are nullable, only then this multiply AND condition will be nullable. But I can say that its child, this one is star, it is true, yes, but it's another child that is A, it is again false. So the condition isn't satisfying, so this star will be false. What is its first pos condition? In the first pos we can say the child 1 equal to nullable. Yeah, child 1 is nullable. So what we're going to do, we're going to union of first pos child 1 and first pos of child 2. That is first pos of child 1 is 1, 2 in the first pass of second child is 3, so we're going to union it. 1 2 3. This is the first pass. And for this, what is it? The last pass told us that if C2 is nullable, then last pass of child 1 and child 2 union. But our child 2 is not a nullable. Actually it is false, so it is not a nullable, so else condition will work. What is it? 3. The last pass of second child, so only 3 will come here. Similarly, let's go to another end condition. We can see that this is false, this is also false, so for this one it will be false, that is not nullable. Now for this one, both of the childs are false and C1 is not a nullable. That means my this part won't be satisfied. Else condition, else is first pass of only C1. So what is the first pass of child 1? Child 1 is 1 2 and 3. And for the last pass, since both of them are, since C2 is also not nullable, so it will be the last pass of child 2, that is only 4. Again for this one, both of are false, so this will also be false, that is not a nullable. And since child 1 is not a nullable, so only child first pass will be of child. Similarly, since B is not a nullable, so else condition will be followed and the last pass of the child 2 will be taken as the last pass. And finally for this part also, both of these are false, right? So this will also be become false, and its first pass will be added in condition. Says C1 child 1 is false, so else condition, that is for only the first pass of the child, that is 1 2 and 3. And since C2 is also not a nullable, so last pass of C2, that is 6. And thus I found the nullable first pass and the last pass of each nodes. Now what we're going to do, we're going to find follow pass, the step 4. We have found nullable first pass, last pass. Now we're going to go to the next step, that is step 4, follow pass. How we can identify follow pass? Follow pass only works for multiplication and star. Follow pass means, what is the next term? Now, if I see here, if I have a multiplication condition, there are two childs C1 and C2. Child 1's last pass, each element of last pass will have value of child 2's first pass. That is, 1 will have access to 3, 2 will also have access to 3, but 3 will not have access or these numbers. Similarly, if there is a star, then what will happen? The last pass of child will have access to its first pass values. So 1 will have access to 1 and 2, 2 will have access to 1 and 2. We're going to now look into the examples and it will be much more clear there. Here the thing has been written all over here. The first pass, follow pass and the nullable conditions that we have already figured out at the start. Now we're going to only find the follow pass. So we know the follow pass rule, that is for this one, this, for this one, this. So let's just visualize what we have explained earlier. We're going to create a table for follow pass that will have all the symbols and its nodes numbers. Now check here, this is the OR condition. We know follow pass doesn't work for OR, so we're going to go to the next term, that is star. Now we know that each elements will have access to its numbers of these elements. So 1 will have access to 1 and 2, 2 will have access to 1 and 2. So we're just going to write those things here. We know node 1, we said node 1 will have access to 1 and 2, and node 2 will also have access to 1 and 2. Now we've come to this in multiplication sign. So we know this is one child, this is another child. This child last pass is this term, and for this child this is the first pass. So 1 2 will have access to these things. So right, 1 will have access to 3, 2 will have access to 3. So I'm just going to write here 3 and for 2 3. Now this multiplication, its child 1 is this one and child 2 is this one. Its last pass is 3 and its first pass is 4. 3 will have access to 4. So for 3 I'm just going to write here 4, and I don't think any more will come, so I'm just closing it. Okay. The next term is this one. Multiplication sign again. Is child 1 is this one and the child is this one. Is last boss is this one, is first boss is this one. So 4 will have access to 5. I'm just going to write here 5. Similarly for this one, this is another child, this is another child. 5 will have access to 6. Just writing here 6. Then come hash. Now there is no further one, so for 6 it will be empty, null, and thus we are able to find the polypos of each terms, and this is it, and we have completed our step 4. Okay, so let's continue to the next step, that is 5, our last step, that is transitional table for DFA. We have completed our polypos table here, and now we're going to complete from there our D states, and we're going to draw the DFA right here. So here, okay, so initially the first state will be the first box of the last node from the syntax tree. So if we see the syntax tree here, the first box of the last node is 1, 2 and 3. So this will be the first state. So we're going to just write here 1, 2 and 3. And we're going to assign it A. A is a state. So we're going to also write here A. We have to see 1. So 1 is here, and we're going to come here and also see the node number. So 1. From 1, my follow pos is 1, 2, 3, which is the same as this one. So from 1, I get the same thing. So I don't need to write anything new. From 2, let's say come up here. From 2, I get 1, 2 and 3 also. So I also do not need to write anything new. Now from 3 I can see that I get a new one, that is 4. Therefore, what I have to do right now, so for 1 I know I get 1 to 3. For 2 I also get 1 to 3, but I don't want to write anything initially because it was the same. But since for 3 I get a new one, so I'm going to write for 1, 1, 2, 3. For 2 the same thing, and for 3 I'm going to write 4. And thus this is my new state. Initially, if I didn't have 3, so I wouldn't have write this new term. But since for 3 I get the new term, that is 4, I am writing a new state. Otherwise, if 3 also represented 1 to 3, I would have kept 1 to 3 as it is. No new state would have been written here. Now, I have here some terminals, A and B. So, first of all, I have to just write a new B state. Okay. Now, from A state, how can I reach B state? Now, for this, there are some terminals given here. With the help of these terminals, we're going to determine when I am going to go to B state. Okay, for this one, I am going to come up here and see. For 1, there is symbol A because node represents symbol A. For 1, I get 1 to 3, which is representing A. Another term, that is 3. It is also representing A. So, and it represents 4. So my new term 1, 2, 3, 4 is coming because of A, because 1 represents 1, 2, 3 and 3 represent 4, and this both is representing A symbol. So when I get A, I can reach to B state. Now for case B, B is only 2. Only 2 represent B, and from 2 I get 1, 2 and 3. I don't get the 4. So I cannot reach the B state because B represent 2 and 2 has only 1, 2, 3 in its follow-up. So it is the same as this one. So when I get B, it will be repeating itself here. Now the next term, B has 1, 2, 3. Okay, from 1 I get 1, 2, 3. From 2 I get 1, 2, 3. From 3 I get 4. Now from 4 I get what? 5. So this is my new state. Then I am writing here all the terms 1, 2, 3, 4 and 5, because from 4 I get a new term. Thus this is my new state. Let me write here C. Now how can I reach C? Okay, this will be okay. From B, let me check 1 and 3. This both represents A, and for 1 I get 1 to 3, for 3 I get 4, which is the same as this one. So I cannot reach C from B with the help of A. That's mean it will going to just repeat here. Now let's see for small b. 2 represents small b. From 2 I get 1 to 3. And 4 represents small b. From 4 I get 5. Thus, from small b I can reach C. Therefore, with the help of small b, from capital B, this is B state, I can go to C state. Now from C, 1 represent 1 to 3, 2 represent 1 to 3, 3 represent 4, 4 represent 5. Now 5 represents 6. So a new state has come. That is 1, 2, 3, 4, 5, 6. And let me just write here a new state, that is D. Okay. So when I will can go to D, let's see, 1 and 3 represent A, and from 1 I get 1 to 3, from 3 I get 4, so it is representing B only. So when I get A, I am going back to B, and when I get small b, let's see, 2 represent 1 to 3, 4 represent 5, and 5 represent 6, so I can get to the new state, that is D, by small b. Okay. Now for D, 1 to 3 represent the same thing. Now 6. 6 has no new, the 6 is empty. So no new state will come. This is the final state. So let me just double circle it because this represents the final state. And from D, let's we know 1 and 3 represent A, and from 1 and 3 I get 1 to 3 and 4, which is the same as B. So again, from D, when I get A, I will go to back to B. And from this one represents all the two, which are 1, 2, 4, and 5. These represent the same thing as this one. So when I get B, I'm going to stay in here. That is. And thus my DFA has been created for this grammar. I hope you understand. If you still have confusions, do watch the videos again. Thank you.